Hi everyone, I'm Aruna, Assistant Professor, Department of Information Technology, SNS College of Technology. In this lecture, I'm going to teach about the Armstrong axioms for the functional dependencies. Before watching this video, please watch my previous 3 videos. In that thing, I'm detailedly explained about the functional dependencies and its types. So in your Armstrong axioms, there is a two types. One is a primary, another one is a secondary. Secondary can be arrived based on the primary rules. So the first one is the reflexivity, augmentation, transitivity. These are the primary Armstrong axioms. It depends on the what we discussed in the previous video, types of functional dependency. There is a relation between these two things is available. And also secondary can be derived from the primary attributes. Secondary is the union, composition, decomposition, and pseudo-transitivity. So in the reflexivity is nothing but the all trivial functional dependencies, we can call it as a trivial reflexivity, because here y is a subset of x if your x determine the value of y. So it can be represented like this: x is the subset of y, then x tends to y. Now also in your trivial, we are saying itself is a functional dependency. So x can able to identify x. The roll number can identify roll number. Name can identify name. Mark can identify mark. So by using a name and roll number and name, it can identify the name means this is also a trivial. This type of a thing we can call it as a reflexivity. Second one is a transitivity. Transitivity is similar to the type. In the types, it is very much similar to transitivity functional dependencies. So it is indirect dependencies. If x determine the value of y, y can determine the z, then the x must be determine the value of z. So that I have to represent this thing. Best example is this one. So Ram is a sibling of Sham. Sham is a sibling of Mohan. If these two things is a functional dependencies, we can able to identify directly, indirectly, we can able to say definitely Ram is a sibling of Mohan. If any one of the statement in this thing is missed, means we can't able to say the Ram is a sibling of Mohan. So this both the condition is true. So indirectly that we can able to say the third statement is definitely going to be true. So for that only I am quoted one example, that is name tends to mark. By using a name, we can able to identify mark. By using a mark, we can able to identify a department, means definitely by using the name, we can able to identify the mark of the particular student. So these type of axioms, this type of a rule, we can call it as the transitivity. The next thing is the augmentation. Augmentation is nothing but the attributes can be added in the left side and the right side. For example, it is a partial dependency. We can't able to say it is a fully functional dependency. It is a partial dependencies. In augmentation, if x determine the value of y, then xz determine the yz value. So for z can be added in both x component as well as the y component. Mostly in our mathematical relation, if you want to any simplification, we're going to add both the side by the same value. The similar cases, a new attribute. Here new attribute is that if it is added in both the side, x and y, then we can call it as a, that type we can call it as a augmentation, and also this is a partial dependencies. For example, here my x variable is roll number, my y variable is name. By using a roll number, I can able to identify the name, means definitely by using a roll number and mark, I can able to identify the name and mark. So these type of axioms, we can call it as the augmentation. One thing in keep it in our mind. So augmentation is not a fully functional dependency. It is a partially functional dependencies. Secondary rule. So in your secondary rule, the first one is the union. Union is nothing but the, we're going to take it as a common between the both the thing. That can be called it as a union. Where we are using a union means by joining the two relation, or while joining the two table, we are using the union operation. So for example, if x determines the value of y, and definitely x and x determines the z, means definitely by using an x, we can able to determine y and z. That is, we are joining the left hand side of the part. For that thing, we are using the union. For example, roll number determine name, roll number determine mark, means So by using an union operator or union axioms, I can able to join the right hand side. So that is the right hand side is name and roll number, name and mark is joined together. So by using a roll number, we can able to identify name and mark. So these type of an axioms, we can call it as a union. The next one is a decomposition or a splitting. It is a reverse of the union operation. In union operation, we are joining the two right side component. Here we go into splitting the right side component. So and also axioms of decomposition is also called as a splitting or a project rule. So for example, if X determines the Y and Z, then X can determine the Y and also X can determine the Z. So these type we can call it as the decomposition. Similarly, see here in the Y determinant part, we are having a Y and Z. I can separate that one. Y separately and also Z separately. For example, name and marks is my X component. Department and course is a Y component. So if this one is a true, definitely we can say name and marks identify the department and the name and marks identify the course. So these type can be called it as a splitting or project rule or a decomposition. The next thing is a pseudo transitivity. Pseudo transitivity is nothing but, so if X determines the Y, definitely Y is a determines the W. Then we can say X is also determine the Y. For example, roll number and name. The roll number can identify the name and the name and marks identify the department means. So roll number and marks, we can able to identify the department. So this is deals with the left side of our part. That is X determines the Y and Y determines the W means definitely X Z determines the value of Y. Because we know that thing, if any of the element is a subset of your X component, definitely that is a function. That is very much similar over here. It is also very much similar to transitivity. Transitivity is an indirect relation. Here also indirect relation, by using the two things, we can able to identify the third part. So based on these two conditions only, we are identifying the third part. So only it can be called it as the axioms of pseudo transitivity. The next thing is the composition. Composition is nothing but the same value. That is, we are joining the two relation having the different functional dependencies. We are joining that one. For example, X determine the value and A determine B means definitely XA determine the YA. It is a combination of union. So union can be applied for both the same X component as well as the determinant as well as, and also for the dependent, we are using a union operator. For example, roll number identify name and mark identify department. Then we can say roll number and mark identify the name and department. So this type of a thing can be called it as a composition. So in the summary, so in this thing, in this particular lesson, we are seeing about the various type of axioms. So the axioms can be classified into two types. One is a primary, another one is a secondary. In the primary, we are seeing the 3 and secondary, we are seeing the 4 axioms. So totally, yes, 7 axioms is present here. In your primary, we are seeing transitivity, augmentation, etc. And the second one is the secondary thing. Thank you.